Hello everyone, welcome to build a modern Angular application with signals. I'm going to be your author for this course. My name is Deji Adesoga. I am a front-end engineer at Enterfive Inc. I have 5 years of industry experience working with JavaScript technologies. You can also find me on YouTube at youtube.com/decodeangle. Over on YouTube, you'll find me creating tutorials on JavaScript technologies such as Angular, React, Vue.js, Node.js, and including vanilla JavaScript. Recently, I asked a question in one of the Angular communities I belong to if anyone has started using signals in their Angular project. The answer I got was a staggering 83% saying no, while only 16% of the Angular developers who took part in this vote said yes. This now brings about the next question: why do we need signals? So the first point I would like to highlight here is the steep learning curve. Since the introduction of Angular in 2016, Observables and RXDS have been the major way of managing states and sharing data in an Angular application. Despite Observables and RxJS having huge capabilities and a well-crafted design pattern, these technologies have made the learning curve required for understanding Angular a steep one. So much so that it is admitted as a fact on the RxJS website. Another point I would like to highlight is performance, bundle size, and productivity. Before signals came into play, Angular relies heavily on a library called Zone.js to dictate any changes that occur in an Angular application. What this means in essence is that for every minor change that occurs in an Angular project, the Zone.js library would need to execute the changes throughout the entire component tree of the project, which brings a negative effect on the overall performance of the Angular application and also makes the bundle size of the application to be bloated. The combination of these two effects would lead to reduced productivity, as the bigger an application gets, the more time it requires to compile the application, which eventually leads to reduced productivity. With the introduction of signals in Angular, we can now build a complete zoneless application that does not rely on the Zone.js library to detect change, which significantly improves the overall performance of an Angular application, as well as reducing the bundle size of an Angular application due to the fact that we can now go completely zoneless. Having said all this, the overall objective of this course is to go through 5 intense modules where we are going to make use of signals to manage the entire state of our Angular application. From declaring variables to utilizing the various APIs available in signals, we will get to witness the reactivity of signals without the use of any third-party libraries to spread data across our Angular application. In addition to this, we will also utilize the newly introduced concepts in Angular like the deferrable views, the newly built-in control flows, which includes the @for and the @if blocks. We would also make use of standalone components as well as lazy loaded routes. By the end of this course, we would have put together all these concepts to build a shopping cart application. Moreover, you would also have gotten enough knowledge and confidence to also upgrade your Angular application to the latest version and integrate signals seamlessly into your project. I guess you might have been wondering, what are the needed prerequisites for you to take this course? For you to take this course, you need to have a prior understanding of JavaScript and TypeScript is necessary. You'd also need to be familiar with RxJS and Observables, because at some point in the course, we're going to try to convert Observables to signals. And also, you need to have an intermediate experience working with Angular. If you're able to meet these prerequisites, then you should not have any problem following along with this course. And with that, let's get started with this course. In this lesson, we will go over the architecture of the projects we are going to build in this course. We will also go over how we configure our Angular application, which adopts a modular and tree-shakeable approach by making use of standalone components as well as lazy loaded routes. We will also make use of the deferrable views, which was newly introduced in Angular 17, as well as the latest built-in control flows. But before we get started by looking into each of these features, I would like us to quickly go over the backend architecture for this course. You should have it in mind that we will not write any code on the backend, but I would like to show how the architecture of the backend, which contains our REST APIs, is built. So you can start it up when you have access to the project in this lesson. So quickly, let's head over to Visual Studio Code. Inside of Visual Studio Code, we can now see the complete configuration of our backend project. As you can see, our backend is created using Node.js, Express, and MongoDB. You do not need to have an expert knowledge of these three technologies. To get started with the backend, all you need to do is just to download the project, which will be made available in this lesson, and then head to the root of the project and run npm install. Once you run npm install, you need to head straight to the MongoDB Atlas website, create a new project, and then locate where you can grab the MongoDB URL and then paste it inside of your .env file. Then for you to be able to push the static data we have here straight to MongoDB, you need to create a CDA file, which is already in the project, and then run node cdar.js inside the terminal. That will push all the data we have right here straight to the database, which means we'll be able to access it in the front end using a REST API. I think that's all is required for you to get started with the architecture of the backend. Now let's quickly head back to the front end and look into the details of the project architecture of our Angular application. In the front end of our Angular application, the architecture of our project has four distinct features. First one is the standalone components. Then we have the functional and lazy loaded routes, the deferrable views, as well as the newly built-in control flows. Looking at the standalone components were first introduced as an experimental feature in Angular 14 and were fully integrated in Angular 15. In the previous version of Angular, bundle size has always been highlighted as one of the major drawbacks of adopting the use of Angular to develop a web application in comparison to other front-end development frameworks. With the integration of standalone components, we are able to reduce the bundle size of our web application by removing unnecessary imports and enhancing the modularization of our web application. The adoption of standalone components does not mean the default ng module-based approach has been discarded. The two approaches currently coexist. To determine if a component is standalone, inside of the arts component decorator in our TS file, we're going to see a key with standalone set as true. Next up, looking at routing. Routing is a major feature of a single web application. As a user who is navigating a web page, you want to easily switch to different parts of an application without having to deal with delays and long load time. And as a developer making use of standalone components, it makes it easy to configure lazy loaded routes in Angular applications, which doesn't depend on ng modules, which could lead to a robust code base. As you can see on the page, this is a sample of a lazy loaded route, which makes use of a functional syntax, which is much more cleaner and easy to understand. Another feature included in our project architecture is the introduction of deferrable views, also known as defer blocks. This was introduced in the latest version of Angular, which is Angular 17. With this feature, we are able to reduce the initial bundle size of an Angular application. This results in a faster application that improves the speed of the initial load and core web vital results. In the case of our shopping cart, we are able to show a beautiful spinner to the users while the data is being fetched from the backend server by using the @loading defer block. Using the newly introduced deferrable views, we get to lazy load the list of items available in our store with a single line of declarative code. Let's take a look at this in the browser. As you can see, we are now on the landing page of our projects. Let's take the position of a new user coming to this page. At first contact, the user types in the website, which gets to reload. And as you can see, we are presented with a beautiful spinner while the data is being fetched from the backend. This is an example of a deferrable view. The impressive thing about this is that all the intricacies of this feature is taken care of by Angular, which leads to a great developer experience as well as a great user experience. In order for dependencies with a defer block to be deferred, they need to meet two conditions. First, they must be standalone. Non-standalone dependencies cannot be deferred and will be eagerly loaded even inside of @defer blocks. And secondly, they must not directly reference from the same file outside of the defer blocks. This includes @view child queries. So if you are using the old versions of Angular, with these latest updates, you should consider upgrading your application so you can have access to these very powerful features. Finally, we have also utilized the newly built-in control flows introduced in Angular 17 to conditionally render content on the templates. We now have the @if block and @else block for conditionally toggling the contents of the template, while we have the for block for rendering items from an array. As you can see on the page, this is the old way of rendering a conditional content on the page. On the next slide, you can see how to render the same content making use of the if and else block. With this new syntax, you can see we get to write lesser code, which is much more relatable to JavaScript developers, and it's much more elegant. And for the for block syntax, which you can see on the slide, the track property is introduced. With the help of the track property, we get to track changes as they occur in the list that is being rendered on the page, especially in cases of stateful elements or animations. Before we wrap up this lesson, I would like us to take a brief look at some of this syntax in our Visual Studio Code. As you can see in our package.json file, the version of our Angular application is version 17, which is the latest version of Angular. And taking a look at our routes, we make use of the functional lazy loaded routes, which is newly available in Angular. On the product component, you can see we're making use of the latest @for block to render items on the page. We also made use of the defer block to defer the page and show a spinner before the data is being fetched into the front end. We'll look into this in more details as the course progresses. Another thing we need to look at is the @if and @else block. You can see we conditionally render the PayPal button as well as the login button based on the login status of the user. And also you can see that we made use of the standalone flag set as true. That is, every component in this project is standalone. We can now wrap up this lesson. In the next lesson, we'll look into how to get started with signals. In this module, you get introduced to the concept of signals in Angular and why it is relevant to the Angular ecosystem. We will also cover the importance of signals and the problems signals intend to solve in terms of performance and reducing the complexity of writing an Angular application. And with that, let's get started with the rest of the lessons in this module. To get started with this lesson, I would like us to quickly look at the meaning of signals. According to the Angular website, a signal is a wrapper around a value that notifies interested consumers when that value changes. Signals can contain any value from simple primitives to complex data structures. You read a signal's value by calling its getter function, which allows Angular to track where the signal is used. We'll look into more of this as we progress with this module. But for now, I want us to take a closer look and compare and contrast between RXDS observables and signals. When it comes to setting states in signals, signals make it easily accessible in every level of an Angular application compared to observables, which requires a certain level of complexity to share data between different components. We're able to emphasize the need for the introduction of signals, which helps to resolve the issue of complexity and reduces the steep learning curve, because when you look at RxJS observables has so many operators that it will be very difficult for someone coming from a JavaScript background who hasn't touched any framework or library to wrap his head around the different RxJS operators we have, which I think is about over 100 different operators. So the steep learning curve that comes along with learning Angular, making use of observables, is what Signals has come to simplify. To proceed with this, I would like us to take a look at a code example that compares signals to observables by creating a counter operation in Visual Studio Code. Now that we are inside of Visual Studio Code, before we get started, I just want to quickly explain the setting we currently have. So we have a new Angular project, and inside of this Angular project, we have a component called RxJS-Signals. This component has a template with a text of hello world, which is reflected in the browser on the tab on the right hand side. We're able to display the text on the browser because we imported the tag for that template inside our app.components.html file. Nothing difficult. I think that's totally clear. And with that, we can now start our implementation of our counter operation to help us to compare how state is being set, making use of RxJS observable in comparison with signals. So for the first implementation, we are going to make use of RxJS observables as well as behavior subject. So to do that, we need to import behavior subject and take. So we can just import that above, as you can see, and down below we can create a variable called count, which also has a pound sign or a dollar sign rather. And then we can assign it to the new behavior subject and set the initial value to 0. Next thing we do, we create our function. So we're going to call this function counter, and within this function, we're going to create a new variable called latest count. We set the initial value to 0, and then we're going to instantiate our count variable, which holds our behavior subject above, by saying this dot count with the dollar sign, and then we make use of the pipe and then make use of tick, which is going to be 1, and then we need to subscribe to this observable. Then we call an arrow function, which has a variable of x, and then assign latest count and set it equals to x. Then below, the final thing we need to do is to call next by initiating the this.count variable once more, and then calling .next, and then we can now say latest count plus 1. With this function, we should be able to create a counter operation that increments the value of our count variable. So to see this in action, we head straight to our HTML file and then get rid of the hello world texts, and we create a div. And within this div, we're gonna create a text called count and make use of string interpolation, and then instantiate our count variable defined in our TS file and pass an async pipe to be able to display the value of the observable in the browser. Another thing we want to do is to create a button. So I'm going to type in button, and this button is going to hold the count function. So I'm just going to say click, which is the click event handler, and then I'm going to call the counter function, and then let's call the text counter. So I'm going to save everything we've done so far and wait for the browser to refresh. As you can see, we have a button called counter with count holding an initial value of 0. If I click on the counter button, you can see the value increases to 1, and then it keeps increasing as I click on the counter. So the next thing I'm going to do is to comment everything in the template as well as what we have in our TS file and try to implement this making use of signals. To do this with signals, the first thing we need to do is to define our variable. So we can do that by saying count is equals to signal, and signal is nothing but a function which takes in an initial variable. So the initial variable, just like we did in the observable, we set it to 0, and then the next thing is to create the counter function. But before we proceed, you can see we have an error which says cannot find name signal. This is because we need to import signal from @angular/core. So I'm going to import signal, and then that error disappears. So we can proceed to creating our function by typing counter, and then within the counter function, I can just say this dot count dot update, which is a method available when we define a signal. More information will be provided about this in the coming lessons for this module, but for now, let's just implement our callback by saying passing an arrow function, and then type in C+1. So we can now save, and then in the templates, we can display the variable we set in our TypeScript by creating a div once more. And within this div, we can just say count, make use of string interpolation, and then call our count variable. And it's going to hold a parenthesis because signal is nothing but a function. Finally, we can now define our button by creating a button tag, passing it with a counter text, as well as the click event handler, which helps us to call our counter function defined in our TS file. So we can now save, and then on the browser, we can see the initial value is 0. So once again, if I click on the button, you can see it increments by 1, just like we defined it in the TS file. And as you can see, the advantages of signals over RxJS is glaring. You don't need to subscribe. You don't need to pass an async pipe. The code syntax is elegant and simplistic in nature. I think with that, we've been able to exemplify the concepts of why signals is introduced into the Angular ecosystem. In the next lesson, we're going to look at the importance of signals over change detection.
Thanks for watching. If you want to keep learning, click the link in the description below.